Hello everyone, and welcome to my channel. Recently, I've been tinkering with the Klipper's user interface, and it started with this Klipper box that uses an OLED display module, a power on-off button, and the rotary encoder. And in this project that followed, I made a macro pad with interactive LED indicators. This macro pad improved my Klipper experience significantly, and LEDs allowed me to monitor key system status at a glance. And the buttons allowed me to quickly make essential commands. Later, I put the breadboard prototype into this Klipper box that has a fancy touchscreen, as you can see here. But honestly, I felt that these buttons and LEDs were even more useful than the touchscreen because it's so quick and easy to use. However, these cables plugged directly to the Raspberry Pi made the macropad non-modular, and Raspberry Pi will run out of GPIOs soon for any further expansions in the future. So in this video, I'll try to fix the problem by adapting an extra MCU, namely the Raspberry Pi Pico. We'll get plenty of additional GPIO pins from the Pico, and it will reduce the connection down to a single USB cable. So let's get to it. Here's a plan for today. In this old version, I connected LEDs and buttons to the Raspberry Pi's GPIO and programmed it with macros and display templates for each of them. The whole code was made as a new file and linked to the printer.cfg in the existing system. But today, I'll channel all these wires to the Pico's GPIO, then connect this Pico to the Pi with a USB cable. I have already designed and printed a new housing with a slot for a Pico, so I'll put these together while wiring the components. There are many different MCUs that Klipper supports, but for this project I chose a Pi Pico. It's mainly because I could find a nice installation guide for a Pico in Klipper's documents. But other than that, I also find Pico to be very convenient to work with because of its clean and simplified pinout plan, and because it offers so many GPIO channels, 26 in total. Also, Pico and other RP20 modules are very easy to come by for a very low cost, like $2 from sellers like AliExpress. Among the RP2040 modules, I'll be using this black one because it is what I have at hand. Here's an original Pico, but it's wireless version, and I'd better save it for other purposes. This black RP2040 module is pin-to-pin compatible with the original Pico, and it has a USB Type-C instead of microcontroller. There are some other differences, but they are no issue for this project, so I'll skip them. I want to show you some other stuff that I'm going to be using for today's project. Here's a new box that I have 3D printed. And these are the switches, which are Cherry MX style keyboard switches. These are LEDs and current limiting resistors in 1 kilo ohm. The LEDs are about 2 millimeters by 5 millimeters in size, and they are about 7 millimeters tall. The actual work began with soldering the pin headers onto the Pi Pico. And then I installed the Pico to the housing. I used an M2.5 6 millimeters screw for this. Now I'm going to assemble the buttons by simply pushing them into the holes. And the LEDs. Since I designed the holes to be really tight, it wasn't easy to press them in. Eventually, I pushed them with screwdrivers into the holes. Now that the button compartment is ready, let's think about how to wire them. And here's a switch with 2 legs, and of course an LED with 2 legs. But you should correctly identify plus and minus leads for these. Now with 5 of the switches, I'll be connecting 1 leg from each with a wire and use it as a ground rail. To connect the LED, I'll be using one 1 kilo ohm resistor to limit the current flowing through the LED. And the rest of the LEDs are connected in the same way. Now I'll wire the remaining lead from the switch to one of the pins on the DuPont connector, and connect the positive lead from the LED to the remaining connector. And the same for the rest. Okay, now the ground also needs a 1 pin DuPont connector to be inserted to the Pico. And all of the rest will be inserted to the GPIO pins, again on the Pico. With this plan, I started to solder some wires, beginning with the ground line. as you can see, the pins on the buttons that are closer to the LEDs are going to be connected as a ground rail. This is the 1 kilo ohm resistor for the LED, and it is connected from the negative leg of the LED to the ground. By the way, I have explained how I measured and calculated the current limiting resistor of 1K in the previous video. So if you're interested, please follow the link above. Before moving on, I did some tests to make sure there is no problem with the soldering. The button compartment and the box fits together like so. They were fused together with some super glue. Looking back, there was no reason why these two had to be separated in the first place. Now let's connect them to the Pico. I have already prepared the wires with one end terminated with a dip-on connector, and this was plugged to one of the GPIO pairs on the Pico, and the other ends were trimmed appropriately and soldered to the switch, then to the LED. I did the same for the remaining pairs. And this last one pin dip-on cable, is for the common ground. Here is the GPIO pins I used. They are GP6 to GP15 in sequence, and I used the pin 18 as the common ground. Now that's it for the wiring, and I finished it up by closing the lid. And placing the keycaps I made. The keycaps are 3D printed with top layers in black filament. If you're interested in how to post print to swap filaments, there is a link on the top of the screen. So how do we make this module to work in Klipper? There is a mention inside the Klipper's official document in the chapter titled Measuring Resonance, and there you should find the Pi Pico under software installation. This whole section is for attaching an accelerometer. However, the MCU setup according to the guide is good for any general use, not particularly limited to an accelerometer. We just have to follow the direction line by line, and to do so you have to open the SSH connection to the Klipper using the terminal. I copied the commands in the terminal and set the make menu parameters to match the instruction. Now I connected Pico to the Pi while pressing the boot cell button. After that, I compiled the firmware for the Pico, again by copying the commands from the instruction. The process always ended with error, but in the message is the alternative command that you can try, which could be copied directly to the command line. And it worked. And here is the command to check. And there it was, the RP2040 listed in the devices. Now the remaining steps deal with configuration of the Klipper system. In the printer.cfg, I wrote this line, which tells Klipper to process an additional configuration file under the name of macropad.cfg. After saving and exiting, you can create the file with this button, create file. With the file name you have chosen in the printer.cfg. Since I have already made the file, I'll cancel this and open this already made file. First comes the MCU definition. I named it a Pico, and from now on it'll be called with this name. And in this line, you have to look closely for this ID, which could be copied from the previous terminal window. So here is a definition of an LED. It is named as LED heat cool, and it is connected to GPIO pin 15 on the Pico. All LEDs in my script has a cycle time of 2 seconds to allow the blink that turns on and off every second when defined with the brightness value of 0.5. What follows is the display template for the LED heat cool. And as you can see, many of the LEDs are paired with display templates. In a nutshell, a display template is used when you want the LED to reflect any system status autonomously regardless of your button input. In this case of indicator heat cool, it allows the LED heat cool to work even if it wasn't triggered by the button. In this template, there is a script that reads the printer's heaters and set the LED to blink when heaters are set and change it to solid on when they reach within range of the target temperatures. And the LED is set to off when the heaters are off. By contrast, some of the LEDs are defined without display templates. For example, this one, LED bed mesh. That's because this LED's action is scripted in the button macro below. Here, if you compare the macros for these two buttons, this heat cool button requires no LED operation inside the macro as it has a display template. Whereas in this macro for bed mesh button, the LEDs are set to blink or off as it didn't have a display template. Okay, back to the LEDs. There are 5 LED definitions, and the LED heat cool reflects the heaters as we have already discussed. The LED bed mesh will blink if the printer is working on the bed mesh calibration. The next one is the LED safe config, which has a display template which is set to turn on the LED when there is any system parameter change that requires to be saved, such as new calibration dataset. Anyway, next one is the LED pause continue, and it will blink to let you know whenever the printer is paused. The LED e-stop will simply turn on if there is a printing process underway. After this, there are 3 simple templates that are meant to be used in button macros. After the LED and their display template definitions, there is this delayed G-code macro that activates all of the LED display templates above. This way, the LEDs with display templates are made to work autonomously regardless of the button presses. After that, we have 5 macros for 5 buttons. And the functions of the buttons will be easily understood by their names. For example, the switch bed mesh will perform bed mesh calibration. And the heat cool switch will start the heaters or turn them off depending on the current status. It reads the status with this line. In the same way, the pause continue button will either set the printer to pause or to resume printing, depending on the current status. And the emergency stop button and the save config button will be self-explanatory with a simple G code. And that's it. Again, I didn't explain every detail of the code because it could be found in the previous video. Here's a demonstration. That was all the function of this button and LED macro pad, and I hope you enjoyed it. So hope to see you again in the next one, and happy 3D printing. Bye.